Hello students, I am Dr. M. Velumani, Assistant Professor in the Department of Civil Engineering. In this video, we will discuss an important topic from design of steel structure, namely types of compression members and the basic of codal provision for their design as per IS 800-2007. Introduction to compression member. Compression members are structural elements that carry axial compression forces. Examples include the column in buildings, stud in trusses, post in towers, and roof trusses. The performance of a compression member mainly depends on its slenderness ratio, which is the ratio effective length to radius of gyration. Failure of compression members may occur due to their crushing and buckling. Classification of compression member. Compression members are classified based on their function and structural role. Columns are primarily vertical members that carry a load from slabs and beams to the foundation. Studs are secondary compression member used in the trusses and bracing system. Posts are relatively light compression members used in the towers. Depending on load transfer, compression member may be main member or secondary member. Short and long compression members. Compression members are also classified based on their slenderness ratio. A short compression member fails mainly by yielding or crushing of material. A long compression member, on the other hand, fails by elastic buckling even before reaching the yield stresses. In practice, most structural columns behave as intermediate columns where both yielding and buckling strength. Types of sections in compression member. Compression members, various steel sections are used as compression members. Single roll sections such as angles, channels and I sections are commonly used for the moderate loads. For heavier load, build-up sections formally lacing or patterning are adopted. Box section or the tubular section like CHS, RHS and SHS offer excellent buckling resistance and torsional rigidity. In some cases, composite sections combine the steel and concrete are used for improve the performance. Axially loaded compression member. In theory, a compression member may be axially loaded where the load passes through the centroid. In such a cases, stress is simply the load divided by area. However, pure axial compression is rare in practice due to the unavoidable eccentricities. Most compression members are eccentricity loaded, resulting in a combination of axial compression and bending. This increases the stress and deflection and reduce the load carrying capacity. Buckling in compression member. Buckling is the most critical failure made of compression members. Depending on the section and loading, buckling may be occur as a flexural torsion or flexural torsional buckling. The theoretical buckling load is given by Euler's formula, which shows the buckling load decrease with the increase the effective length. The effective length depends on the end condition of the column. For example, column with both end fixed have lower effective length compared to column with a hinged or free end. Buckling curves in IS 800-2007. The design compressive stress depends on the yielding strength, slenderness ratio and buckling behavior. The account of improve and residual stresses based on the IS 800 provide for the buckling curves, namely A, B, C and D. Each curve represents the different types of cross section and buckling mode. The design compressive stress is obtained using the reduction factor, which reduce the yield stress based on the effects. This ensures the shape and elastic estimation of a actual loaded capacity. Build up compression members. When load are very high, build up compression members are such as a laced or patterned column are used. These members are increase the stiffness and buckling resistance and most safety codal requirements for spacing, slenderness and connection design. Compression members are widely used for in multi-story building, bridges, towers, gantry girders and modern steel structures. To conclude, the compression members design as a covered mainly by slenderness, buckling, behavior and codal provisions. A clear understanding of effective length, buckling, curve and reduction factors is essential for the safe structural design. Thank you all.